Okay, number one, this is a Half-Life problem, and the Half-Life, we use the same form as the exponential um, growth formula. So we're starting off with this formula. Okay, so you want to use the idea about half-life. How long does it take to become half its original amount? So this one says that it takes 69 years to become half. So we don't actually need to know how much to start with the a sub 0. We could write something like this. It could still be a sub 0, but we know that after 69 years, we will have half of the a sub 0. Okay, so to solve a exponential equation, we first start by dividing both sides by this constant. So a sub 0 is there to represent a initial amount. So we want to get rid of that. So we're going to divide both sides by a sub 0. What that's going to do is those are going to divide out, those are going to divide out, and we're going to get something like this. 1/2 equals ek 69. So now all we have to do is solve for the k, and that's actually the first thing that we're asked to do. Calculate the decay constant, the k. So we have to bring this exponential down, and to do that, we'll have to introduce log. So we could choose any log. We could take a log base 10, a log base 7 or so, but since there's an e there, what I'm going to do is I'm going to do a natural log of both sides, because the natural log will undo the e. So those will go away, and we'll have something like this. Okay, all we have to do now is divide both sides by 69, and so you have to use your calculator to natural log 1/2, and then press enter, divide that by 69, and you get a constant that is negative 0.01004561113. Okay, so that answers the first part, the decay constant. The second part now says calculate the amount remaining after 200 years. So in the second part, they're telling you the time. They're saying that let t be 200. And they didn't even give you a starting amount, so you're going to still call the starting amount a sub 0. And you just want to know how much of this a sub 0 is left. So we're going to set up our equation like this. Again, we're going to go back to the exponential growth decay formula. We're going to plug everything in, including that k constant that we found. And so now our formula looks something like this. We're going to have a sub 0, e. I'm going to abbreviate the k here, but it's negative 0.01. Keep in mind when you go to do the calculation, use the full number. And we were told that the time is 200. Now, we want to figure out how much of this a sub 0 is left. So we want to figure out how much the percentage of a sub 0 that's left. So this is, we're solving for its percentage. Okay, so we're going to divide both sides by a sub 0. That's going to cancel the a sub 0, a sub 0. So now it's saying that there's a percentage that's left, and it is this. So all we have to do now is just use our calculator and calculate that percentage. Again, use the full numbers. This is just shorthanding, writing it down, but you want to use the full number for the constant and then multiply by 200 and then use it as an exponential. So when you go to solve for this, you're going to get 0.13410. So you could change it to a percent, and we could say that there is this much of the a sub 0 left, 13.41% left. Okay, number 3 is a sound problem. For all the sound problems, you guys are going to use this formula. It starts off, it looks like this. Okay, so dB is the decibel. It always has a 10 log I is the intensity, and then I sub 0 is the threshold intensity. So we are asked to figure out by how many decibels does the loudness increase. So the intensity of a certain advertisement is 4 times greater than the show you are watching. So the I value is 4 times the intensity, I sub 0. And that's all you need. You're going to plug that in to your equation. So when you plug it in, you're going to replace the I with 4 I sub 0. You still have an I sub 0 in your equation. So what that does is actually it divides out the I sub 0, and all you're left with is just this. So now you're just going to type this into your calculator. When you type that into the calculator, it will tell you that the decimal level is 6.02. Okay, number 5 is another sound problem. It says prolonged exposure to sounds above 85 decibels can cause hearing loss or damage. So they give you guys a couple different cases, and we're going to solve for the decimal level, and anything above 85 we will say that prolonged exposure of those sounds will cause hearing loss. So A, vacuum cleaner, it says the vacuum cleaner, the intensity level is 1.10 to the 7th. So what that means is that for this one, the intensity level is 1 times 10 to the 7th, as intense as the I sub 0. So you're going to say something like that. And then you're going to use the same formula. 10 log, you're going to replace the I as 1 times 10 to the 7th I sub 0. Down there, there's the I sub 0. That's going to cancel those out. So you're just typing this into your calculator. You're to say the decibel level is 10 log 1 times 10 to the 7th. So if you type that in, you get 70. So prolonged exposures to vacuum cleaners will not cause hearing loss or damage. Okay, so thunder. It's 1 times 10 to the 10th. So the intensity is 1 times 10 to the 10th as much as the threshold, I sub 0. So you're going to use the same formula. You're going to say for this one, the decimal level is 10 log, and then up here is supposed to be the I, but now you're going to say it's 1 times 10 to the 10th I sub 0. I sub 0. That's going to allow me to cancel those. And so I'm just typing in 10 log 1 times 10 to the 10. So when you type that in, it gives you a decimal level of 100. So 100 is greater than 85. So prolonged exposure to thunder could damage hearing. Okay, so busy traffic. This one is just saying that the intensity level is 1 times 10 to the 8 as much as the threshold, I sub 0. So same formula. The decibel is calculated by using this formula, 10 log 1 times 10. And then these get canceled. If you guys go and type this into your equation, you're going to get that busy traffic gets you a decibel level of 80, which is below the 85, so that won't hurt your hearing. We could do the same thing for explosion, and for the explosion, if you guys do the same thing as parts A, B, and C, you guys are going to get a decimal level to be 140, which is greater than the 85, and so it could potentially cause hearing loss or damage if you are exposed to loud explosions.